Thank you. All right. So maybe everybody here in this hall has a smartphone. So the concept. All right. Is it loud now? Everybody can hear me, especially in the back. All right. So the concept of smartphone has emerged in the last 5 years, and now you carry on a computer with you all the time. And it's powerful because you can extend these operating systems by downloading third-party applications. But there's a risk here because anybody now out there can develop an app and put it in the market. And so you use it without looking at who's developing these applications. So because of that, there were a lot of attacks against Android users, against their privacy, and against their phones. So this is like a familiar screen that you see whenever you try to install an application from the online market. It asks you for permissions. And this is the Android security is built on top of permissions. Permission gives these third-party applications the privilege to access your data in your smartphone. So this is the fundamental concept in security, in Android securities. And users got to be careful about downloading the applications and granting those permissions. Because once you grant these permissions, it's just one time. So you have a chance for one time to grant these permissions. After you grant these permissions, the only thing that you can do is by uninstalling these applications to stop them from accessing your data. So as you can see in this screen, there is two lists. The first, in the top list of these permissions, they classify them as dangerous permissions. Whereas the ones that are hidden, and you need to click on the CO, they classify them as a regular or undangerous permissions. So they're not dangerous in the sense that they're not going to affect you. So the literature is full of research and projects on compromising on the users' privacy. And these are some of the publications that we have done, or the work, the projects in in UNC Charlotte. And one of them is about keyloggers threat, and about also the OAuth, the implementation of OAuth on smartphones. So we found that it's vulnerable, and developers can easily hack it and steal your username and password. So the theme of our work at the UNC Charlotte, or in our group, is by detecting or finding out what are the potential threats that may be targeted against users, and try to find a mitigation on defensive mechanisms. So as I said, the focus has been on the dangerous permissions, and there are very few work on the regular permissions. So we ask ourselves, so this is the research, the question is, can we use the regular permissions to compromise users' privacy? So in so doing so, to prove or to answer these questions, we investigated the components of Android application. I forgot to mention the reason we chose Android. So the same concepts apply maybe in the majority of platforms, but Android, because it's open and flexible, so we can download the platform, we can change it. Also, we can get the source code of an applications downloaded from the market. So back to our research question, can we compromise users' privacy in Android using only normal permissions? To answer these questions, we had to go into details into the components of Android application. And these are the main components of any application. We got the activities, content provider, and the broadcast receiver, and services. And if you don't, the Android manifest file, this is also comes with, shipped with the APK file. It's inside the APK file that you install in your machine. It has all the configuration and some useful information that you can learn about the application that you're downloading. To get this manifest file from the APK, you don't need a lot of hard tools or sophisticated tools. It's easy. And also you can reverse engineer the source code or the application to learn the developer's behavior and their security choices. So we looked at all of these and asked ourselves the question, if we have only normal permissions with these given components, can we compromise users' privacy? So the content providers, just to give you a hint about each component. The activity, it's the screen that you see and whenever you play with an application. The content provider is the component that manages the data of an application. And the broadcast receiver is the sleeping agent. That's why I call it sleeping agent, because you're not aware of its existence. And the services that runs in the behind the scene. So the question was on the broadcast receivers. We found that the broadcast receivers can play a very dangerous role because the users, they don't pay attention to these broadcast receivers. And the user's understanding of application is, as you are working with the application, playing with it, it can access the permission and it can access your data. But once you close it, there is no access. And once you turn off your application, you can't access anything. You can't run any code. But with broadcast receivers, this concept is not true. Because with Android, with the broadcast receivers, you can register your application to listen to the Android system events. So the application is sleeping, it's dead. And whenever something happened, it will wake up and start performing some actions behind the scene. So this gives a powerful and dangerous capability to malicious applications. And the way you register those in your application as a developer, you can register them dynamically in the source code, or you can insert them on the manifest file, the configuration XML file. And the difference is the dynamic, there is no problem with dynamically registering these broadcast receivers because it makes sense if the application in the foreground and it's active and running, it has the right to look or listen to the events happening on the system. But if it's on the XML file, then this breaks the security and the user awareness. It listens to the events even if the application is not running. So to gain more insights, we started looking at these broadcast actions. So each broadcast consists of an action. So whenever an action happens in the operating system sends all this action to all the registered applications, and then the application that receives this action can read some more insights about the action and perform something behind the scene. And also we build a scenario where we can use a broadcast receiver and a normal permission to monitor users' geographical location. So first, let's look at the evolution of these broadcast receivers' actions because so far we have 19 releases. And you see the growth of the number of broadcast actions from day one, from the release 1 until release 4.4, the KitKat version. So overall, there's an increase by 79%. So the more actions we have, the more information we're going to reveal about our internal behavior of our operating system to the third-party applications, which are not supposed to be trusted. And also, it's not just increasing by the numbers over the different releases. Some of these releases, sometimes we add more, sometimes we remove, sometimes we sub. And some of, like when you add a new actions, the way you explain this by adding a new actions is with the evolving technology and hardware. For instance, the Bluetooth did not exist in the past, so that we did not have any action to report that the Bluetooth status changed. But the removing some of these actions, we did not yet find an answer to this behavior in the Android platform. So the use case scenario, we build an app that only has one activity, and we registered a broadcast receiver. And these are the broadcast receivers. That means my application is going to listen to any connectivity change, any network ID change, and any state change. And all of these considered by the security experts as a regular and non-threat that does not cause any threat on the user's privacy. So I did that. I installed it in my smartphone, Android smartphone. And whenever anything happens like this, I log the ID for the network and some other information about the network. The information that you can access without needing dangerous permissions. So I kept this on Google Docs just for this experiment. And I noticed that I can aggregate this information, for instance, over a week or over a month, and I can learn when the user is leaving his house, where does he work, and some other information if he also goes to some of the coffee shops. So this is also very dangerous if somebody knows if he learns the behavior about you, when do you leave your house, and when you want to come back, where will you work, and what time you leave your work, especially if he's your boss. He can know what time you leave the work, right? Okay, so even the information, more than that, the information that we collected, by just analyzing this information by itself, we can learn, we call it like internal analysis. Without using any external knowledge, we can learn some private information about about the user. And also more than that, we can aggregate more information to whatever we collected. Like if you know that there is a database online that map an SSID for Wi-Fi's to a geographical location. So you know exactly where this user exists right now or located. So, and users, they're not willing to share their location, including myself. So by using these regular permissions, we were able to retrieve a user's location without asking for dangerous permissions. So then the research question here is, yes, we can use a regular user permissions and to compromise users' privacy. But we went further and we want to look at the broadcast receivers because we found that this component nobody has touched before and it's worthy of investigating. So what to do in this regard after we realized that broadcast receivers can be of a great help with only normal permissions, and they can compromise users' permissions. So if that's the case, then we have to look at these broadcast receivers and see how developers are using them. And we need to help the users to be more aware of these broadcast receivers whenever they try to download and install an Android applications from the market. So for this, we are working now in parallel in two products. The first thing is to build an app, third-party app, that help the user visualize these broadcast receivers. So now after he installs the application, he can see which application is accessing what. And also we need his help. We're trying to help them, but at the same time, we're trying to help ourselves by collecting this information. For instance, if we know which applications is using what broadcast receivers, we can make some conclusions on that some broadcast receivers or some applications, it's normal from them, it's a normal behavior from them to ask for certain broadcast receivers. And also we ask them to give their opinion about how they feel about this application accessing this broadcast actions. And in the second project, we try to change the Android platform in a way that we change the way we display the permissions. As you have seen in the first slide, they're classifying the permissions into dangerous and normal. But here we found that the normal can be dangerous if there is a broadcast receivers. Then this classification has to be revisited again and take an effect on displaying this permissions in the first hand. So instead of having a static classification of permissions, we can do it on a runtime. When we read the manifest of each Android application, and then we display this based on our dynamic classification for these permissions and see how users act and how users click on these windows. So besides, we found also there are multiple issues, another 2 issues with broadcast actions in Android. The first thing is the conflict. Starting from KitKat version, sometimes there is a conflict between third-party applications. If 2 applications register to listen to a particular action, let's say SMS received, then application A registered first, then and then application B registered again to receive also or to listen to SMS received action. So A can deny B from accessing the SMS. And so we need also to help the developers by grouping all of the broadcast actions and see what broadcast can cause conflict between different applications. So because the developers, they know that when we install an application, it should work. They should register broadcast actions and it should work fine. But we have to help the developers by detecting these conflicts. If there is a conflict happening on the Android device, we have to inform the developer of this conflict. A third thing is the battery life. When you have an application that is registered to listen to whatever action happens in the Android operating system, this will trigger the application multiple times into executing code in the back, which cause the draining of the battery. So we grouped all of the broadcast actions since the first release of Android, and this to help us visualize and to help us resolve conflicts. And towards changing the Android platform, we've done like a minor modification so far, and we compiled and we got a new image. We added some system apps into these images, and now we are investigating how to change the package installer to change the way we display permissions dynamically. So, and the conclusion of my talk is we said that normal permissions, we asked the questions if normal permissions can cause or can compromise users' privacy alone. And towards achieving that, we investigated the other components of these applications, which are the activities, broadcast receivers, content provider, and services. And we found that the broadcast receivers are guilty, so we executed them. And so we did more investigation into that, and we found that the broadcast receivers are causing that trouble. So we did more investigation into that. And besides, we are into the process of finishing the app that will detect conflicts and also increase users' awareness, and also changing the Android platform to dynamically classifying the permissions and the displaying of these permissions into users upon the installation. All right, thank you.